Okay, hi everyone. Welcome to another Wolfram language design review, language completeness and consistency discussion about a variety of topics, starting with LeafCount. Okay, proposal LeafCount should take a heads option. Yes, I believe that to be the case.
Right, so that's just sort of background material about, users have asked this and confused.
We can't change the default.
Right, I don't think we should.
Okay, so what is the question here?
Well, when I originally prepared this agenda, I guess I didn't know my lightning would be stolen by a previous meeting. So if you agree that we should have it, then that's great. But then there's also a documentation, some documentation related issues, which are in the next section.
Gosh. Well, we've clearly got to enhance the documentation.
Right. So I have, some suggested notes that on, tentative on the page, or
real should be rational, right?
yes, that was a bad R substitution. Right, so replace the current note with one that says ordinary expressions and then sort of clarify.
Well, you should say for ordinary expressions, LeafCount is based on full form representation.
Okay.
For raw and other atomic expressions, the LeafCount is generally 1.
I guess we can, right, because association is technically atomic. It obeys Adam Q, but it is not, right, it doesn't have a LeafCount of 1.
Why is it considered atom Q?
Because it's not a normal expression. It's some data structure that we provide sort of a fake full form for. And also, rational and complex are
so the full form is just going to look like this.
Yes, but if you do Adam Q on that, you will get true.
Right. There's several kind of low-level expression manipulation functions that just kind of mysteriously don't work or work in weird ways on associations.
But many work as you would expect.
Yes.
Although,
and sort of support for each one needs to be added individually.
Yeah, that's kind of weird already. I mean, because that is not giving you, part 1 of this.
Exactly.
Do I think association is also hold all complete, isn't it?
Yes.
So the association is lots of unexpected properties.
Why is it hold all? Wait a minute. But if I say association of 1 plus 1 here,
it'll run.
Right. But
it does it under its own control. Go ahead.
Yes, exactly. And if you do something like right, but if you had that association and you did, slash dot blank goes to blank squared, it would not evaluate.
Right, or like if you do replace all, A goes right. That doesn't work. That's an example of one of those things on general expressions that doesn't work on associations.
I wonder whether we document that in either in association or in slash dot.
I think it's the same like cases also. I don't think searches keys and stuff like that.
Right. So certainly There, I think I have a list somewhere here about, or at least the start of a list that there are other places where we need to make this thing that we only operate on the values, right? Because like level, right, only sees the values. It doesn't see the keys, right? Because remember back when we used to, what was it that Tali called it? The not the grand principle. He had some name like that.
The central dogma.
The central dogma. Thank you. Right. So, right, that they're really lists. It's just that their parts are expressions rather than numbers. And so, because of that, we have all these functions which only see the values and not the keys.
Right. All right. Well, okay, fine. Is there any more to discuss here? I mean, LeafCount. Why don't you just say LeafCount whenever? Is it the case that atom Q, if atom Q is true, it usually is the case that LeafCount is 1. But what are the counterexamples?
Rational, complex, and association.
Okay. Well, why don't we just list those?
Well, they are listed in the next 2 notes.
Yeah, okay, fair enough. But maybe just a table. I mean, just so people don't.
Okay, so just maybe with the following exceptions.
Yeah, maybe.
And make a little table. All right, I'll play with that.
Fine, but I think this is otherwise seems good. And is there any other issue? I mean, heads, true, false. That should just do it, right?
I think so.
Okay. All right, are we on to the next item?
Yep. Right, so we talked about sort of deprecating the fact that options can take a stream name as a naked string, and then treat a string as a possible symbol name.
Yep.
And so this is sort of a proposal about, and with maybe a couple of questions in there.
Why are we doing this?
Why are we doing what?
If it's neither a string nor a symbol, then why isn't options of, blah, 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 just an error?
Because it's documented to do something. Which it says right there. This is consistent with the documented usage of options of blog gives the explicitly listed options in the expression.
Okay, but it's not explicitly listed if it's options of plot or something. That's not explicit.
Right. Well, right. So symbols are
options
right
of the
there.
result of plot.
What?
So options of
look
plot.
at the input right. Look in the list in the example right above the 1. Right. That's just some general function f of a. Right. And it gave you exactly the things that are options in there.
Wild. I had no idea that worked. It's probably worked since version 1.
And it's been documented for certainly since at least version 6, if not version 1.
So your point is, I mean, you're saying, if it's a normal expression, I understand what it should do.
Mm-hmm.
If it's a symbol, it's doing the special thing. And if it's a string, it's right now also doing a special thing.
Right.
Wow. Okay. It could error out if it's a string. If we're going to the string as an alternative to symbol here, couldn't it just error out if there aren't options? What you're saying is that if I say options of f of a, b, it's just going to return nothing, right? Which is perfectly nice behavior for a normal expression.
Mm-hmm.
But given that we're going to have the special case behavior with a single symbol, why wouldn't we have special case behavior with a single string too? What happens if I say options of no error?
That's correct.
Right.
Yeah, it's an inert object with no option.
So Itai,
Mm-hmm.
what if the case that the string is neither a stream nor a symbol.
Yep.
Are you thinking of the case like you do it for a string that could be a symbol but isn't in the symbol table, or something that couldn't even be a symbol name in the first place?
Interesting.
Okay.
What happens if it's just a bunch of spaces?
Right. Well, so that's the current behavior.
What are you proposing for this?
Well, again, I favor simplicity, so I would just continue to return an empty list for that.
And what would you return for options of quote capital plot? I mean, are you proposing to do something with that?
You mean
yes, that is the proposal.
The proposal that would be equivalent to options of plot the symbol.
So how would the context be chosen?
I guess. Well, I guess based on context path, I presume, right? I mean, it should be more or less the same as options of symbol of the string. I know, maybe that.
So are you creating a symbol to do this, or does it have to be in the symbol table?
No, it has to be in the symbol table. Right. So this is just like I think attributes, right? Attributes takes right. So whatever it is that attributes does, we would extend to options.
Okay, well, I'll have to look at attributes to see what it actually does.
What on earth is that doing there?
Well, it's looking for a symbol named a bunch of spaces in the symbol table, and it doesn't find any. So
but it doesn't create anything.
It doesn't create anything. No, if you did attributes of X, that assuming you don't currently have, assuming name Q of the string X is currently false, then there would be no symbol created after. That's the whole point of these guys.
Okay. All right. So what's the question here? So the question is.
So are we okay with the sort of stage 1, stage 2?
Well, yeah, let's do stage 1. Let's see whether there's any freak out.
Okay. Right. And there's a question of should statar and statar issue messages, or should, since we're not planning on dropping support for those should just quietly continue to work.
What's the better way to do that?
Well, you'd have to construct output stream of statar, (1) or whatever the full form of, to do full form of dollar streams and
why on earth do we not have something? Because why don't we have a dollar standard output? Dollar standard error. I mean, I think we were reluctant to have that 30 years ago.
So we have streams of standard out, and the thing about that is it returns a list, because I guess it thinks that you can actually have more than one standard output and standard airstream.
Well, if you had a file open called statout-foo, I think it would return it. Maybe I'm wrong, or maybe it just chose to always return a list for uniformity.
Boy, I remember, I mean, there's one of these things where somewhere deep inside, it's like these technology stacks where somewhere deep inside, there's something from just absolutely, I don't know, there's probably a great example of this, of some technological thing where just there's something which is there for compatibility with a thing that's been gone for 100 years. And that feels like what this is. I mean, it's like we're doing this sort of super, well, okay. I didn't even know that this was called statout as the output stream here. So why exactly do we not have a symbolic name for this as an alternative? So that one can think of, well, I mean, you know what I'm saying. It seems like this is a very primitive, version 1 terminal interface type thing.
I vaguely remember that we do. So now, dollar output, is that what it is?
Oh,
well,
yeah.
No, dollar output.
Dollar output is a list of output streams to which you should send output.
And that's the thing that I thought was a list of all the standard outs. Okay, because
Yes.
you could see that it's a list of standard out.
Right.
Right, but particularly in the
but you can
notebook.
you can append to the point of dollar output is you can append to it and then write to multiple files at once.
Yeah.
Yeah.
Okay. And then my comment was going to be, correct me if I'm wrong, there's no analogous dollar error.
There's dollar urgent, I think it's called.
Yes, it's called dollar urgent.
Okay.
I mean, that goes to stood out.
Yeah.
Well, I think you could set that to be stood error.
Mm-hmm.
I don't exactly know what happens. I mean, if I say, how do I even do this? If I say write to stood error, and I just write a string, or is it write string?
Yeah. Right. And
Where did it go?
Presumably it went to the standard error, which is probably disembodied because it's, this is a kernel that was started by the front end, and therefore, stat error is not attached to a TTY.
That's a very deeply lost animal. I mean, so what you're telling me is if I go and I go here, what the heck is that? Oh, for goodness sake. Nothing ever works. Growl. How could that be wrong? What is that even? Okay, in any case, let's try it here. Okay, so now if I say write string, oh wow, okay.
Right, because by default, stat out and stat error are both attached to TTY. Now, if
right,
you
but if I
use
said
in out,
greater than 2 or something,
right,
greater than or whatever it is.
Yep.
What the heck is that? I don't even imagine what that is. I thought I was quitting there. Who knows? Okay, in any case, all right, so fine. So what I'm arguing here is that we should have, I mean, maybe we should call it dollar output stream, dollar standard output stream, standard error stream. Does that make any sense? Whose value is just output stream has stood out, output stream has stood error.
Mm-hmm.
I mean, it's just typing more stuff, but it makes it a little bit less kind of crazy Unix, string.
Right, except the argument for keeping stat and stat error is backward compatibility.
Oh, no, we should have the possibility of accessing things that way. I'm just saying that this should be a symbol name that we can document that is equal to output stream out.
Okay, so if this is and also not instead of, then I'm fine with
right.
that.
I'm suggesting it also. What do you think of the name? Standard output stream, standard error stream.
I think those are the obvious names.
Is there no standard in?
There is the standard input stream.
There
already
isn't.
exist or no?
Right.
No, it's got dollar input. Oh God, it's nothing there. Okay, so if I run standard input,
is that just the input? Like if you run the command line program, like that's just the input.
Yeah, I think that if I run it, if I say, I don't know how to quit from here. I thought it was Control D. If I say
Control C, right?
No. What happened is you hit Command D rather than Control D, and you split your terminal. Is what happened before, but.
Oh, I see. Oh, Control Command. Yes. Okay. Fair enough. Okay. Pipe that to that, and then no. Actually, what I want to do is cat. That's not what I want. I want cat dollar input.
You'll need to put single quotes around the dollar input.
ordinary quotes.
Yep. Still empty.
Maybe
Yeah.
just look at the example for dollar input if you really want to
No,
know,
I believe that if I read it from a file, it would be the file name, I think. No,
Yeah, all right.
but-
I think I think that's the point, that it's not attached to
You want echo instead of cat?
yeah, because cat failed.
Yeah,
Not
good
yeah,
point.
yeah.
Yeah.
Oh, right.
We
Yes.
should go through and deal with the .m's here. That's just a note, please, for project management. In dollar input file name, Avery points out. That's right. That's the file name as opposed to the stream name.
Right, because dollar input file name is set if you just do a get.
Yeah. You know, it's just outrageous that we have all these, for goodness sake, can we please try to, could you point this out to Avery? Could you point this out to the documentation folk again? Yet another thing that's version specific. Make sense?
Yep, got it.
Well, this is a very old, my God, this is a version 2. I thought this was version 1. Okay, I mean, anything more to say about this? I'm not sure how important these are, but they would be things that might be nice to be able to document for as we get more and more use of Wolfram Engine and more actual use of our, of things which are essentially low-level command line operations.
Mm-hmm.
Okay, any more to say about this? So the question is whether to give an error on standard, if you use stood out and stood error. I would say let's not give that error for now.
Yep. Okay.
Okay. Are we on to the next thing?
Yep.
Linear solve function.
Right. So this is a question that was sent to TLCC by
Long time
Jan.
ago.
Is it Jan, or I don't know what language
well,
it.
Well, I get called Jan, but my European friends think Jan is easier to pronounce. Up to you.
You can bind all kinds of different names to the same object. Never mind. Okay. I mean, I've asked this question various times. I've never understood our matrix decomposition functions. It's always been like, well, people packed these matrices this way in the 1960s, and everybody's been doing it ever since.
Yes.
What is the? Go ahead.
Right. Okay. So I'm perfectly happy to discuss that question, but I will point out that is a different question from the one that's being asked here. So the question you just asked is, why do we return this crazy thing instead of 2 matrices, an L and a U? Which is, I mean, certainly not everybody still does that. Like, I think MATLAB gives an L and a U. They don't pack them together. And I agree. I mean, I think for usability reasons, we absolutely do want the L and the U separately. We still would need in general.
They were the guys who were like, it was the Fortran tradition
Yes.
to put these things. You can't represent a triangular matrix in Fortran.
Right. LinPack, which was the very, very original implementation of this linear algebra routines, packed the upper and lower triangular matrices in a single matrix because it was a waste of space back in the day to put them separately. Nowadays, we don't have that space issue, so it makes sense to put them separate.
Okay, but let's understand. First question is the idea of a linear solve function. Right, where don't we have, I'm sorry, I'm now confused. We don't have a linear solve function now.
Well,
right?
there
Yes, we do.
is. What that example with N29 should just do linear solve that same input.
That's what I thought. I thought we had, yeah.
Yes, we
something-
do have
Right.
it.
Yes, but the question is, suppose you want to compute your own decomposition for whatever reason. I mean, John claims that he has some faster algorithm, at least, or maybe you want a slightly different form. You want your own favorite permutation, right?
Okay.
Then how do you go from that data to a linear solve function? Is the
Why do you
question.
want to? I mean, so, okay, first question is, who uses LU decomposition disembodied from linear solving? Does anybody care about that?
I think
Sometimes-
it's pretty much there as a pedagogical thing.
And
I
sometimes
think
you
it's a
just need
standard
the
tool.
factors.
You can use it to compute various things. You get two triangular matrices. We
Except
could
you
output
don't.
actually
No.
triangular matrices now.
Except you don't get triangular matrices now.
We don't write.
No, I mean, it's
My
back from,
question
but
is, do people want this as an end in
Yes.
itself?
yes.
Okay.
Yes.
Okay, so what do you do with this other than just admire it?
You can, the determinant is you can just look at the middle entries. You know, you take the product of the diagonal entries.
Right. You've pre-done a bunch of computations that you can then reuse if.
But that's the whole concept of the linear solve function. But
Sure. But you
but
can't.
people don't quite get that idea. So
Right. Well, also linear solve function doesn't actually show you a diagonal you can just read off.
well, you can. I mean, it has these properties, which you know are way before Stephen allowed properties that, so they're not really documented.
Which properties?
Well, we don't document them because it had
but if you do a linear solve function of the
properties.
first matrix, and then so instead of XYZ, you do properties there. I think you'll see them.
Oh God,
You need to close your quote.
I know that. Oh,
Right. Yes, it's got lots of hair. This is before you actually, we had a way of setting up properties at all that was considered documentable.
oh, that's the get all as opposed to the get lower.
Right. Which should be lower, right, or something.
Yes.
Sure. I mean, we could set those up and document them nicely.
But the fact that there's a lower in linear solve is just, I mean, whatever. I mean, I don't care how linear solve works. All I want is something where I can repeatedly solve a linear equation.
Well, it's not really a curried format. I mean, this actually creates something called the linear solve function.
Yeah, I realize. Right. But Dan on our live stream is suggesting, why doesn't LU decomposition return an association? Yeah, I mean, it could do that. But if we had a mechanism to get out from a matrix, you know, I mean, look, we could call it, for example, I mean, because we have to hack the design at this point, in a sense. LU decomposition data could give one with a property name here, or alternatively a curried form. Could give one or an all, just LU decomposition data could go to an association that has all of those things. Does that make sense?
I suppose. I mean, I'm not sure how interesting the function that is.
Well, you guys are telling me that this is.
I don't think we are telling you that.
Well, why is this coming up? Okay, we've got an LU decomposition function. People say it's not packaging its output.
Okay, so well, it's first of all written right there, Stephen. The question that's come up is, if you've computed your own LU decomposition for whatever reason, how do you turn it into a linear solve function? Then there's the other question of how should we package up LU decomposition better? And I think, you know, what people would expect from that is an upper matrix and a lower matrix and possibly a permutation.
Yes, fine. But we can't change the output form of LU decomposition as such.
And I agree with that, which is why I've suggested like an LU decomposition matrix or something like that. Or I don't know what we call it.
Except this, I mean, LU decomposition data is what I'm suggesting for the thing that you're describing there.
But I don't think people would want, I don't think the market that is served by giving an L and a U is served by giving an association, much less one that includes the condition number.
Well, I mean,
I think right.
I don't have any opinion about that. You told me pedagogical purposes. Where would I get the permutation, for example? If I've got a list of matrices, no, it's going to be as obscure to get, for example, if
you get a list, which is a upper diagonal matrix, and we'll have an upper triangular matrix type. So you'll see upper triangular matrix of blah, lower triangular matrix of blah, and then this other thing, which is the permutation.
So you're saying right now we've got two somewhat obscure things that are coming back in LU decomposition. What we want to do is break that guy. I don't even know what that one is. What is that one?
Permutation.
That's permutation.
And what's that?
Right.
Which?
Right.
It's an estimated condition number.
Which only works for, I think, approximate reals, like yes. Machine precision, or maybe also arbitrary.
Have it.
Right.
Yeah.
Whew. Okay. So that's a bizarrely packaged object.
Yes, I think.
Okay, but to get the lower and upper triangular, can I not say of a matrix just lower triangularize? Yes, I can.
Well, it's lower triangularize -1 plus add the identity matrix of the correct dimensions. Why don't you look at the LU decomposition rough page, and then you'll see how painful this is.
That's painful. Is it really that?
This looks like an old version of the documentation, but
it's version 13.0. I mean, how old is old?
Well, that looks like a pre-13.0 basic examples to me.
Sorry, but I'm running.
Open the.
Actually, I'm running the prototype
type, which has some ancient build apparently.
Okay, well, fine. So let me open this in the more recent, in the more civilized version. It's got a time machine.
There we go.
That looks better. Somebody should check on the 13.1 prototype build and its documentation.
I can do that.
Okay.
Right, so that's how you get L. You lower triangularize -1, and you add in an identity matrix of the correct dimensions.
Okay. Aren't there various other matrix decompositions like Schur decomposition and so on? Do they also produce these bizarrely packaged results?
No, this is only this one.
Why? I mean,
This
like
one is old.
Cholesky decomposition.
So the reason is because before we had linear solve function, we had this function called LU back substitution. And LU decomposition gave output in the form consumable by LU back substitution. Right. So maybe the answer to Jan's question is he should use the obsolete function LU back substitution.
Well, you can also plug it into LinearSolveFunction using the full form, but that's a bit of hackery.
Okay, what problem are we trying to solve here? We're trying to solve the fact that we say that in modern times, we think LU decomposition should have been designed to return explicit upper and lower triangular matrices. Is that correct?
That is one question. That is not the question that John originally asked that sparked this agenda item. But That is a related. That is another item that I'm happy to discuss and is related. Certainly.
Okay,
related.
so the question here is, given this weirdly packaged thing in LU decomposition, how do I make a usable linear solve function out of it? Correct?
You're right.
Yes.
And assume that I don't want to start from the matrix because I have my own way of computing LU decomposition that I can turn into that form. How do I then further feed it to linear solve function?
Well, the linear solve function makes the assumption that the LU decomposition is in this packed LA pack form. So,
Okay.
so if you have a packed form of a matrix, you can put it into n linear solve function. I mean, not in a documented way, but it's certainly possible.
Okay, so the question is, could linear solve function take, I mean, validated linear solve functions, could they actually just take as an argument, a single argument that is essentially some kind of LU decomposition output?
Yeah, it probably could do.
It seems like a very, very, very corner case.
Right. It's a corner case. I think that could work. Here's another possible idea for the LU decomposition stuff is right now LU decomposition is one argument, right? I believe. Suppose we put in a second argument and say, you know, the default for that was, you know, quote, packed, quote, or something like that. And then we could have, you know, the possible thing would be the list of matrices to put out, like lower, upper, and the default would just be to return this pack thing to be consistent, but then we could return what we wanted.
Like an association, for example.
Like in an association, right.
Yes.
Okay, but that solves the other problem of different output from, you know, like linear LU decomposition of thing, comma, quotes, matrices might give the lower and the upper.
Separately, yes.
Right.
Okay. But so the remaining problem is there any way to go from a hand-built LU decomposition to, you know, into the linear solve function? Strikes me, I mean, just.
Yeah, if you do linear solve of that input and do input form, you'll see you could, you know, it'd be easy enough to plug it in.
Gosh, I wish when nobody had defined an M here that then is not used for anything else.
Well, it is used in the next input.
No, I know, but I don't mean, I mean, why define a variable and make it something which you cannot do in one shot?
It's used in the text.
Because you're using it in the text.
Oh, I don't agree with this. Okay, in any case, I don't agree with it.
Right, so I do input form of that. And that thing, the 2, true, and then the stuff following that, that is the output of the LU decomposition for that.
Well, it isn't. It is not. This part here is.
That part is the after the true. Yep.
Gosh, I wish this bracket clicking worked in input form.
Wouldn't that be nice?
Wouldn't it be nice? Yes,
If you surround input form with the list, then I believe it will work.
Are you serious?
I'm serious that is my belief. I'm not sure that my belief is correct, but
my golly gosh.
Golly gosh, yes.
That's interesting.
Right, because in one case, right, the whole cell is input form, so you end up in text data, whereas here it's inside, so you're in box data.
That's obvious, but I never thought of it.
Yes.
Why don't we ask John Boltz if he can just make it so it works this way? I mean, yeah.
Just because you can also do Shift Command I on that output cell, and
then it's genuine input form. So I mean, the issue is that there are, well, look, the real point is to just make double clicking work in input form. which could be done, and it should be on the user assistance
Yeah.
list.
I'll
Okay.
let John reply to that point.
Okay. Okay. All right. So I think this is a deep corner case, and I don't think we can be serious about it.
Okay.
Being able to take something that LinearSolve eats. I think the idea of having additional string arguments to LU decomposition sounds highly sensible, and I think we should just figure out how to do it.
Okay.
Make sense?
Right. There was this additional question about why does it never save the factorization for rectangular matrices? Is that just laziness?
Oh, the reason for that is because the factorization, factorization isn't really proper for singular matrices. So it goes back to basically what it does is it goes back to the linear solve thing, which resolves it in various different ways.
So you're saying LU decomposition doesn't make sense for rectangular matrices. Is that what you're saying? And LinearSolve has other ways to deal with non-rectangular.
LinearSolve has other ways to deal with that. Yes.
So in particular, if I were to make this 5, 6 here, that's really funky.
Right. So what it's doing is it's just storing the original matrix, and then it goes back to whatever. So this is preserving that linear solve of blah of argument is equivalent to, linear solve of blah comma argument.
All right, but it claims there is no optimization here that can be made for repeated use.
I think that's not completely correct, but it's to be consistent. To be consistent, probably not.
Well, I don't understand here. I mean, whoops. Why?
Usually you would need to use least squares instead of linear solve in cases like that.
Well, dude, yeah, if you do the transpose, you have a much better chance of having a consistent.
Okay, all right, okay, fine. But my question is, okay, what are you saying? I mean, LinearSolve should do the best it can to save something which can be used for repeated solving. Is it not doing that?
No, and that right, that basically the only thing you can do for cases like that is check it for a particular argument. There may be a consistent solution, but there's no decomposition that's going to work to typically find that.
I'm sorry, could you say that again?
Okay, so with that singular matrix, there may be a particular X, Y, and Z for which you can actually find a solution.
Okay.
You cannot in general, but it depends very much on that X, Y, and Z. So there's not a single decomposition that's going to tell you whether it's going to work for a given X, Y, and Z.
I see. So there's no optimization. What you're telling me is there's no pre-caching of a decomposition that will be useful for repeated solving of a rectangular matrix.
There could be in some cases, but again, those are rare, and you could spend years trying to figure out those cases and keep it consistent with what linear solve does, which I think is a marginal prospect.
Okay, fine. All right. Okay. All right. So I think the only conclusion from this is that LU decomposition needs additional property arguments that can give a variety of matrices, matrix lists of matrices, other things. Any other issues here? Nope. Okay.
Yeah.
Then let's do it.
Okay.
Okay. Manipulating held expressions. Okay. There's a lot of issue here.
Mm-hmm.
Basically,
there's a bunch of stuff with the compiler, which also needs a different mechanism for, well, I don't know exactly what this item is, but there's a bunch of stuff with the compiler that probably relates to it. But Yeah.
Okay, let's understand what the real point is. So we have a symbolic expression, and I can give all kinds of physics analogies to this, but in our environment, as soon as you have a symbolic expression, it will start evaluating. We can protect it by putting protective coating around it of a hold to prevent evaluation. But then as soon as we probe into the protective coat, all bets are off. Right? That's the issue, is what do you want to have happen inside the protective coat? And we've got this inactive mechanism, which is an attempt to micro protect different parts of the machine.
And inactive, by the way, I mean, inactive would be very, very close to, I mean, it would be able to solve lots of problems except for the fact that it has this glaring hole, that it doesn't inactivate atoms.
Oh boy. Well, should we have a version of inactivate that does inactivate atoms? And is that okay? Let's just understand from a theoretical point of view. I mean, back in the dawn of symbolic computing, people thought, well, first of all, most people had a one-pass evaluator. You know, eval was just a one-pass thing. Actually, it was a mess because functions were multi-pass, variables for one pass, and so on. But so, in a sense, inactivate could recurse down and just wrap every little subpiece in coating.
That's what it does right now, but only for normal, like only heads, right?
Right.
That's the version we threw away. We had a version like that that was useless that we threw away many years before.
Well, okay.
So
right, and of course, inactive things are not completely inert, right? If you take the curl of an inactive grad, right, you'll end up with 0 because we can predict what the result of that action is.
Right. I mean, you can apply things to the outside. I mean, just like you can apply length to an inactive expression, you know, but I think that's what you want.
But clearly, the thing isn't the same thing, right? It's been wrapped.
Right.
So the issue is.
Yeah. The issue is that, I mean, I'm interested in what this older version was that wrapped more stuff, because I mean, I think it makes total sense that, like, okay, it shouldn't wrap strings, it shouldn't map numbers, stuff like that. It shouldn't wrap certain things that it knows are inert.
I think what the problem we tried to solve with inactive was to have inert mathematical operators. We have active operators, and we wanted inactive operators. In other words, you can represent an integral formula. So I'm saying that they represent a problem. You can represent an equation with an inactive solve. And that itself is a mathematical expression and operator that you can manipulate.
Okay,
transform.
Listen, guys, look, the thing we would like to have is a notion of a symbolic expression where nothing has a built-in value. We just take the symbolic expression. It's an expression. It has lengths. It has this. It has that. But nothing. In other words, you've got some object, some expression, and it's as if for the compiler, for example, there could be an expression there, and the expression in and of itself does absolutely nothing. Eval is nowhere in the loop. Right?
No,
So,
I get that for program transformation, and there might be more that you want, like storing annotations and properties along the way and things.
Right. So the issue is we could have right now, our internal. So one way to do this, which again, I mean, there's just so many things that are crazy. Okay. So let's give an example. So let's say we have the inactivated version. Or I shouldn't say inactivated. The
passive.
The passive version of it's the symbolic expression. Okay, and that symbolic expression is, plus of times of 3, 2, 1, for example. Okay, that's the symbolic expression. Now I want to test You see, so one thing I might imagine doing is just putting these in a different context, for instance, okay? But the problem with that is, what if I want to test, I want to find the position in that of times.
Or if you want to evaluate it.
Well, yes, but I mean,
Does position work with unevaluated?
quite
Use the
possibly, but
unevaluated plus-
listen, the problem is, as soon as you have the expression, and as soon as it hits the main part of the system, as soon as, we have an infinite evaluation system. It is on a hair trigger for any expression. It's always going to just start evaluating. It reminds me greatly of physics. You don't get to have a sort of a static structure of space that doesn't do anything. But so we are in a sense, but nevertheless, there's nothing wrong with a symbolic structure. It's just that we have this evaluator that's a really grabby evaluator that's coming in and trying to do things with these. But if it was kind of a string-like object, this is what drives me crazy. Let's imagine that we had this thing was in a pseudo string. Okay, I don't know how I'm going to represent the pseudo string. I don't know, whatever it is. This is a pseudo string, let's say. Okay, and so then it is just a thing that you can pick up, you can look at it, you can do, but it on and of itself. Go ahead.
What do you mean do things to it? I mean, because I think the issue is that if you have an operation, right, the way reverse works is that it's like, you apply it to the outside of an expression and it transforms that whole expression when it evaluates sort of gets replaced with another expression, which then of course, evaluates. But this is, I think, the issue is that you can have things that are held and you can have certain functions that work, through the whole, like replace all and stuff like that. But if you want to be able to run reverse on your held expression, reverse needs an actual implementation that doesn't evaluate its output and stuff like that.
Well, okay. Look, one question is.
Let me make 2 points. One is, of course, the issue reverse doesn't evaluate its arguments, at least if if it's a hold of blah or you give it unevaluated. It's just the evaluator sees the expression has changed and starts evaluating all over again. But also just, deciding whether you've matching something can run code. And I have that example there with echo false and and the function f, right? Just deciding whether or not things match can produce evaluations.
Right.
And I don't think there's any way to solve that other than just being careful.
Okay, but the point is, the level of compiled code, there is a notion of an expression data structure that is completely inert. I mean, it only does things when you poke it with, when you actually do compiled operations on it.
Well, it's the same in kernel C code, right? I mean, this is right. So for those who are aware, this is the issue with the compiler right now is that it has.
Just you went caved.
Oh, is that better?
Yeah.
Yes.
Okay. Yeah. So the issue with the compiler is that it has an expression type which just is the kernel C code expr, and so of course if you do something to it, unless you ask it to evaluate, it's not going to evaluate. So you can run reverse on your unevaluated expression and it will reverse it, but it will still be unevaluated, just like kernel C code. So right. I mean the issue is that one option with the compiler is to make another expression type where functions like reverse will actually explicitly ask that their output be evaluated before returning it. So it'll actually have the same semantics at the top level. But in any case, the version that doesn't evaluate, that's like kernel C code, is itself pretty useful. And so
right. So maybe the answer is we need a function that easily converts things to that and
to what? To what?
To the right. So so I wasn't expecting to go in this direction, but we might need Tom or some such. But right, there is they have. Well, I guess Rob's here, so Rob can tell us, right? But right, there is an expression level representation of expressions that's used by the compiler, and that's where all the magic happens.
That's right. But it's actually, as it is now, I think Christopher's absolutely correct. We need different levels of things that evaluate. For example, it's very hard to use right now in the compiler, because suppose you have something that you want to represent as an expression, and you say call times on that. So set up multiplication. Well, what happens is you don't get the properties you expect out of times. Namely, it doesn't create a number. It creates a new expression with head times or something like that. So it's and there are different levels. It's not right now, not totally thought out. So it's not consistent with what it does with times. I mean, should times just create a new expression, or should it actually try to do numbers? And our actual times has all this code, which is deeply enmeshed with the evaluator, that merges numeric constants and integers and stuff together. And so so
I had a use case
thing.
which I think is a little easier, which I suspect is part of what Christopher is after. So a long time ago, I implemented my own C structure, expr structure, long before I started at the company. And part of the reason that I needed that is because I needed to sort of extract things from it without it, blowing up from the evaluator, and that I could have the correct complexity of doing that. I could traverse I could look for many things by traversing it once and things like that. And that is super hard to do with the current sort of expressions. I don't even know how to do it in top level.
I know, that's exactly what we're talking about, Roger. I mean, what we're talking about is a raw expression.
Right.
Okay,
but I think what one can do is kind of extract data from it, like searching it and finding things and positions and things like that. But when you want to interleave that with what Rob was just talking about, like a little bit of evaluation, it becomes super difficult, I think.
Well, it's like a string.
Right.
Okay, a string does nothing unless you poke it. Go ahead. Yeah.
Right. Well, I mean, here's a weird example, right? I mean, so you can imagine having something that's like kind of like an expression, but it's marked so that so it's imagine we had just like a flag in the C expr struct. I mean, this is not I'm not proposing this. It's a terrible idea, but imagine we had a flag in the C expr struct that would tell it not to evaluate when you call eval on it. Then you would imagine. So the question is, certain functions that are written in C, they could work just fine, right? And then but now imagine like how would a function with like a down specified with a down value work, right? So where you input one of these non-evaluating expressions and it gets ripped apart and its constituent pieces get put in 15 different places in this new expression. And then those ripped apart pieces will sit unevaluated where everything around them evaluates, and it just becomes very, very hairy, very
well
fast.
And then occasionally then you have to ask the question, are two unevaluated x's the same? Are they equal? Are they same Q?
You mean because one of them might have evaluated earlier when x was equal to 2 and the other might have evaluated later, for example, when x was equal to 5?
Yeah,
sure.
Yes,
right.
But if it's a true symbolic expression, the obvious answer is yes, right?
Right. I'm just saying that, like, the point is that I think, if we had something, the point is that we like to think of stuff like hold as being like, this outer wrapper and so on. But there are functions that will, rip apart the expression and evaluate these parts and not evaluate those parts and move things around in all sorts of ways, so that the part that was originally inside of the hold may be ripped up and moved into 15 different places. And so it's not as simple as just then returning another held expression, because some parts of it you need to evaluate and other parts don't, etc.
Right.
I mean, I guess inactivate kind of does some of that, because it at least lets you have sort of bits that are unevaluated. But yeah.
Yeah. I mean, I think inactive, if using I never use inactivate, but using inactive around certain heads, like I've constructed, compiler code often by using, inactive of compound expression and, various things, and then activating it inside the function. I don't think inactive itself is that useful a tool, but inactivate is not a useful tool, but inactive by itself, where you put it exactly where you want, is quite
Exactly.
useful.
Yeah, I think that's the main use case we have actually.
Well, right, but the thing about atoms, I mean, inactive is great, but inactivate is the only one that I think is problematic, because that's the one that doesn't, if inactivate put inactive around X, then I think it would be pretty good.
Are you sure? Because I think that if it did that all kinds of comparison things will get weird, all kinds of depth counting things will get weird. I mean, we're using a hack that basically heads are not usually gone down. That's really the hack we're using. And if that head, I mean, I suppose if you have, what happens to curried forms? Do we put the inactive on the head of the head of the head?
I don't think so, but I think that would also be good.
Well, okay, but I mean,
Christopher,
okay.
what do you have an application in mind? Because it might, even if the general case, we all get lost.
We do. Look, listen, it does put it on the head of the head of the head.
Oh, never mind.
Yeah.
Okay,
yeah.
Look, I would like to say that I think there's a general thing, which is just metaprogramming of, just manipulating code. I want to do transformations. I want to do pattern matching transformations on code. I want to replace a for loop with a table, for example. How do I do that? I've got a for loop sitting there and, in a piece of code, and maybe it's in a notebook. Maybe it's just in raw code that I read in. And now you're right to ask, how did I get the code in there without it evaluating?
Well, that was kind of my use case from when I wrote what I did also.
Yeah.
I was writing compilers basically. So but one of the things that is missing in that is that you need to build a model of assignment and state if you're going to look at that level of generality. And you need a little bit bigger machinery, I think, to do that realistically. You need to model state transitions.
Well, okay,
right.
so you're claiming
that's true if you're doing that level of analysis. But I think that there's more basic stuff. I mean, there's more basic stuff just around just moving expressions around where you don't want to have to sort of tiptoe super carefully to make sure it doesn't evaluate and that you don't accidentally unwrap something.
For the more basic stuff, do you essentially just want something that's like hold form, like it looks like the expression, but it's invisible to the function above it in the way that unevaluated is? Like it doesn't.
No, because as you go in, look, as you
extract things and it auto wraps them in something so that it just looks like the expression, but it wraps it in something so that expressions don't get evaluated.
Well, the problem is, when does it do the wrapping? Let's say you're doing pattern matching. Does it leave it pre-wrapped when you're doing the question mark? When you're doing the
like the pattern would match just the underlying expression, but the result would wrap it.
Right. And let me point out that the moment you do blank underscore, blank question mark odd Q, you've lost the game. Right. Because there's no way that odd Q can know, oh, this is a special type of expression, so I shouldn't allow, the 1 + 1 to evaluate to 2.
Exactly. I mean, this is I think what we sort of started with, which is that, I think this is sort of the difficult thing is I think that what the sort of behavior that you'd like, that you're sort of expecting, is to basically have a whole set of implementations for all these functions like odd Q and reverse and so on, that are sort of implementations that know that they're going to be eating some unevaluated thing and that they know not to try and evaluate it. Right. But I think that's sort of, and again, I mean, maybe some of those can be sort of stolen from the compiler, because the compiler basically has a bunch of, such implementations, as well as things that kind of exist in kernel C code. But I'm not sure that's the best. I mean,
this is such a losing thing, because the fact is, as soon as you say +1, you've got something you're trying to say, is this equal to that +1? And then it just isn't going to evaluate the +1. It's just going to sit there.
Right. Exactly. And that's what I was saying was the problem with the stuff in the compiler now. You do a +1, you expect it to be a number, and it may or may not be this unevaluated thing, which then you have to go and check. And
well, that's what, yeah, right.
Yeah, so it becomes really hard.
Right. That's why people, what does in a REPL, for example, how many times do you call eval? I mean, do you do eval until you get to a fixed point? That's effectively what we're doing all the time.
Yeah.
Okay, so let's think about this. I mean, the issue is, okay, we've got these blobs of unevaluated data that are inert symbolic expressions. I mean, I suspect the basic point here is that we have to do a bit of heavier lifting. Somewhere we're going to have to do something that isn't, I mean, okay, what will be the perfect version of the calculus of inert expressions? I would claim one possible perfect version is it's called times, but it just isn't, it's, well, okay, to what extent is it like an active of times? Maybe it is just like an active of times. Am I making sense? I mean, in other words, what's the difference between what what does inactive not do?
So I think the problem is that inactive doesn't preserve the hold attributes. So take an example that I use a lot, which is sum. So sum has hold all attribute. But if you do inactive of sum to stop sum doing its thing, now suddenly it lets its arguments evaluate.
May I make a meta comment about our discussion here? Basically, there are all kinds of leaks in this boat. And, Jose is pointing out one leak. Christopher is pointing out another leak. I mean, okay, so leaks in the inactive boat.
Well, yeah, we thought about going down the path of allowing attributes to be inherited by the inactive thing, and eventually decided that was a bad idea. Like the stability.
Attributes are not inherited, symbols are not wrapped.
I think it's the same problem. I don't think we want to prevent symbols or to wrap symbols. If sum preserved the hold attribute, then its symbols inside would not evaluate.
Well, I understand that those are slightly related problems. I'm just saying I believe there are many leaks in this boat.
Yeah, I think that the symbols one, I think, is actually, I would argue, is slightly more fundamental, because the problem with that is that if you call inactivate on an expression and then you activate it again and specify that like it be held as you activate it, like if you just remove all the inactives, it'll actually be different because it'll have evaluated things, right? But like if you call inactivate, I mean, if you have a hold all function or something and you inactivate it and then you sort of get rid of the inactives, it'll still be the same thing. The problem is just that if you yourself write inactive of sum of blah, 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 then you'll have a problem, which is a legitimate issue though.
Right. And of course, we haven't even talked about scoping, although I think that happens at evaluation time, not at parse time. So maybe that's somewhere beyond.
Okay, let's return again to the problem that we actually have, okay? So I want to, use cases, right? And the major use case is metaprogramming. So I've got I don't know how to write this. For I equals 0, I less than 10, I plus plus, echo I or something. This is a bad idea. This is such an unbelievably bad idea. Okay, and let's say now I want to do a code transformation to this. Okay, now what am I going to do? How do I do this? What would you advise me to do that code transformation? Should I do an activate of this?
I mean,
I was muted. I would wrap it in hold and use replacement rules.
I agree. Yeah.
Will that work? Like I mean, but wait a second. If I wrap it in hold,
it's not so easy. If you try now to change the 10 to 100 and do a rule replacement, it's not going to be trivial. And we have tricks. If you just do
well, if you do 10 goes to 100, that'll work.
That's easy. But if you want to change the table, it's hard.
The squaring, exactly. Do integers go to integer square? I goes to so x underscore integer go to x square. So that inserts the 10 to 100, right? 10 to 10.
0
10
squared and 10 squared.
Exactly, instead of 100.
Right. And of course, there are ways around that, but
Exactly.
And what would
Right,
those
but
ways
here-
be?
but-
I mean, so if I
right.
do colon greater than evaluate of that? No, colon greater than.
No.
How do I do it?
No,
you
we need
you-
a width.
Yeah, you need a width and a condition.
Okay,
So-
okay. So it has to be lexically done. So there is no, I mean, one thing here, there is no evaluation, whatever it is, delayed, delayed exploding evaluation, so to speak.
Wait, do you mean something where you ask replace to evaluate it immediately?
Yes, yes. i.e., a version of replace that evaluates upon replacement.
So
But-
in
by the
Well,
way,
I
just
think
as
it
a
would be a
note-
special right-hand side for
Yeah,
a
it'd be a
rule,
wrapper.
but-
Would it, or would it be a slash dot, a special slash dot?
I imagine it would be a wrapper on the right-hand side.
Okay, so then this would be immediate evaluate.
Right. But
Evaluate
right,
always.
or something. Right. But, I thought Stephen was talking about the problem of transforming that from, a for to a table, which, that's pretty straightforward to do because you don't need to evaluate anything. You just need to match the pieces and rearrange them. Right.
Is it really straightforward? I mean, so, okay, so
it's not realistically, because there ends up being issues about like, oh, well, if it's just I is less than 10, it's fine. But if it's I is less than anything else, but
I don't even know how to change the for. I don't know how to get the pieces out.
Hold pattern, right? Of
Oh, God.
I
Right,
think
it's
it's
a whole
easier with the inactive form, but that's
yeah.
yeah.
I mean,
but
by the way, another note is, of course, the inactive one. If you take the inactive one and do slash dot 10 goes, or x goes to x squared, then that one will work.
So here,
right. But of
x
course,
blank integer goes to x squared. Yes,
Yeah,
but
see,
that
that's
only works because of the non-wrapping of atoms.
Right, but that's because it's
Right.
it's not, nothing's going to explode in your face because 0 is going to get evaluated.
well,
right?
it
That's
also
fine.
works because of the thing Jose was complaining about. If we had, I think 4 is, I can't remember if 4 is hold all to begin with, and then it processes stuff or not. But if we respected the hold, then you can't do transformations like this inside sum if we get
right.
have what Jose wants.
Certainly module is hold all.
Yeah, exactly. But
So-
that's what allows me to use inactive of module effectively, because I can evaluate stuff inside as I want, and then get the expression, as it is. If it was hold all, then it would be completely useless.
Right. I mean, I don't really understand what, I mean, should that not work? That case we just did above. I mean, I don't really understand what the alternative is.
Well, I think it's great. I think it's great that it does, Christopher. That's one of the one of the things I think that makes inactive useful. Maybe we could have an option or something to inactivate that would go ahead and wrap symbols and atoms and stuff like that.
Right.
the
Yeah.
thing you're
I guess the
writing, I
question
don't
is,
think
do we treat symbols differently from other atoms? And of course, there are some atoms that we technically ignore, right? Like sparse array.
Right. I mean, I don't think it looks at atom Q. It just looks at the expressions. Yeah, no, that won't. I was gonna say that won't work because the blanks pattern.
Right.
So
I like
What?
that.
you have to say inactive of 4 as a headdress. Then it might
Beyond
actually
the
work.
inactivate.
And also inactive, yes. And then also you need to use inactive on the increment and maybe on the less than.
Yeah,
and-
I
and
know.
Probably on the set.
Yeah. Well, you may remember or
But
not,
why was-
Stephen, but-
Well, I suppose he could try using ignoring inactive and seeing if that, right? If you use the full form of replace all, there is the ignoring inactive option, which may or may not help in this case, but it's
Why does
hard
it-
to
no,
reason
why does that
about.
help?
So I can't tell you if it will or not.
What do you mean? It's got.
Is that not an option to?
No, we
replace
did.
all?
We decided against doing that because that involved changes to the pattern matcher, which proved to be pretty much impossible.
Okay.
So yeah, one of your thoughts, Stephen, was to have us have an option to ignore inactive inside the pattern matcher, but you know, I discussed it with Tom, and it was impossible.
Oh, it's a headdress. That's my right. Ignoring inactive is a headdress. So if you'd wrap ignoring inactive around the whole left-hand side of the pattern, then maybe that's where I got confused.
So in ignoring inactive here
Yep.
of inactivate.
Yep. But it didn't help. So
I think the problem is that the blank, X blank is inactive of blank, isn't it?
yeah, that right. You may need to do like an accept of verbatim of blank in your inactivate, but I don't know.
What on earth is that? Why is that expa still blue, for example?
I know that might be a small front end bug.
That obviously a front end.
Well, because blank of it's inactive of blank of expr, not blank of expr. Or
yeah, I don't think I don't think the front end is that clever, but maybe it doesn't know about it.
An activate of X blank is still, it's not rodentifying inside the X blank.
Oh, that's bizarre.
Yeah, it is. Oh no, it's not.
No, it's not.
That's totally bizarre.
No, pattern is probably in the excluded list.
Right.
What is there a way of accessing the excluded list?
Developer backtick and activate exclusions. We wanted to promote these as system symbols, and Stephen objected. So
inactivate, what is it called?
$ inactivate exclusions.
Oh my God.
Yeah. Right. And so these are, so it's, so symbol ones means, so these are ordered pairs. If the second argument is symbol, it means don't wrap this in inactive, but head inside and look inside of it. And expression means if you see this guy, then just stop right there. This is this is a quote unquote data expression, which shouldn't evaluate.
Although that's very dangerous because, B-spline function, who knows what's in the B-spline function? It could be right. It could be literally anything in there. Like, I guess this is the thing that's, okay, I guess this is the issue with inactivate, is just the fact that, it tries to be a little bit clever about what it's going to hold and what it doesn't. But the thing is, it's like, if you imagine writing a program where it's like, you're writing an API and someone gives you a piece of code and then you need to check it and make sure it's safe, and then you might evaluate it or something. But like, you absolutely cannot do that with inactive because there are just so many holes where crazy stuff could happen.
Yeah.
Right. And as Roger was saying earlier, the point of inactive was to allow you to do math. Like if you literally wrapped every 2 and every X in an active, then it gets hard to sort of talk about, this integral.
Okay, let's zoom out again. The main problem that we have is that eval is just, eval is everywhere. What we're trying to do is we're trying to have expressions where, okay, we got 2 problems. I claim there are 2 fundamental problems. Okay, basic problems. 1, eval is everywhere. And 2 is times is the same, I shouldn't say times, I don't know, plus is the same plus, should be the same plus everywhere. So in other words, we can't really have it, in other words, if eval is everywhere, we can't say that the plus, we could have a different plus that was immune to our standard eval, but then it's a different plus. As soon as it's the same plus, eval is everywhere. Now, we could imagine, okay, question. Could we have a different main loop?
That's a very scary thing to say.
Yes.
Yes, it is, Christopher.
Yeah. Right. And of course, yes, I was going to add, right, it's not just eval, it's also subst eval or whatever it's called, the thing that scans down values and applies them one at a time, or all sorts of which is where most evaluation leaks, unintentional evaluation leaks come from.
What would a main loop? Unfortunately, this follows my meta theorem of evaluators. The only evaluator that does nothing wrong is an evaluator that does nothing.
It's nothing.
Yeah.
Yeah.
And a main loop whose evaluator does nothing.
I mean, that's kind of like that's kind of like how it works both in kernel C code and in the compiler, where there's basically no main loop.
Yes, right.
When you apply a function, it just produces a new expression, and then that's it. There's no, it's done.
Right.
Which of course relies on the fact that the implementation of those functions doesn't rely on the loop being there, which most functions do.
Well, a lot of cases, so that's one of the big differences. As somebody who writes a lot of kernel C code still, and have for a long time, that's one of the big difficulties in writing kernel C code is sometimes you want to call some other function, but you always have to check whether that function expects that things have been evaluated or not. And if you call it when it's expecting evaluation and you haven't evaluated, you're typically going to get wrong results in very unpleasant and sometimes very hidden ways.
Right. And yes, and saying that, right, saying that there's this sharp line between C code and, I mean, it is technically true that there is, but it's a bit misleading, right? Because some C code function you call may itself call eval to process some portion of its arguments.
Right, of course.
Absolutely right, Itai, and that's very common. What the C code allows you to do is manipulate. Basically, it allows you to manipulate the expression tree and then evaluate when you want to.
Right.
Okay.
Okay, so it's all Ian. So it's trees. So it's Ian's problem. I'm done. Okay.
Well, you can make ASTs from everything, but that doesn't really help us.
I mean, it might a bit, but yeah.
Yeah, we could use the compiler AST stuff to do stuff, but I don't think that.
So here's another.
I think that's a bit of admitting defeat. Is if we have this beautiful expert code as data thing, and then we say, well, actually, we're going to use this data structure to move them around.
Right.
Okay, turning everything into ASTs is just a more, is basically a more extreme version of inactivate.
Mm-hmm.
But I mean, if we turned everything into ASTs, okay, so then the problem with that is then we need, new versions of every function, of every relevant function to operate on AST expressions. Okay, here's an idea. Okay. What if there was a thing, this isn't quite a well-formed idea. It's kind of like an activate, but yeah, I mean, if you have a function, clearly, which is dealing with inactivated stuff, you can always say activate to take the thing that was inactivated and activate it, so to speak. So in other words, if you have inactivate of 1 plus 1 plus 1 plus 1 plus 1. Okay, we're hopefully inactivated there. And now we say
inactivate. No.
Well,
oh, thank you. Inactivate. That's why I thought it wasn't turning all purple. I mean, all brown. Okay, so activate that. Does activate have any kind of oh wow.
Oh,
I could-
I'm muted. I was muted. I was telling you, right? Both inactivate and activate take a pattern of heads to inactivate or activate, which is,
Okay, so then in this case, what I could do is I could say plus of blank blank. Oh God, this is not going to work, is it?
no, because it's matched against the heads. So you could do like plus or times, but all right, and that was sort of.
Oh, I see. For which that matches that. Okay, so if I say inactivate that, and then I say times, activate that with times, whatever.
Right, so times evaluated and flattened.
Yeah, right. Wasn't any flattening. I mean, there was just.
Or yeah, I guess we removed
Yeah.
which is why it types it differently.
But I think what you want here is not, I mean, it's easy to give the head level control, but probably what you want to do is you want to activate some part of that expression, right?
Yes, probably after a replacement.
We talked about, I don't know if Avery can find it because this was like 2 project managers ago, but I think we created a ticket about extensions to activate and inactivate, which it was long enough ago and we didn't have anybody to work on it at the time, that I don't remember the details, but we may have already gone down the road of designing some extensions to activate and inactivate, which I know maybe we want to reconsider now, but.
A possibly useful function might be something like activate part.
Yes, I definitely had, by the way, a thing. Does anybody know what it was? Expression, unevaluated expressions, maybe. What's it called? I definitely had a thing here for this. Yeah, I mean, so look, something is going to have to do some heavy lifting here. We're not going to be able to get away. There's not going to be a trivial answer. Because again, arguably people who've studied programming language semantics in a different world from the one, in a parallel universe where such people had actually studied symbolic programming sometime in the last 40 years, this might have been properly studied, but I don't think it has been. There's probably basically theorems that basically say you can't get everything you want here. But I mean, again, the real thing we want to be able to do is this metaprogramming, manipulating code. Oh, we've got a thing called code transformation. Look at this. We've got held code transformation. Held code 02, 2016, only 5 years ago, 6 years ago. Evaluate in place, evaluate at, goals, insert an evaluation before processing. That's the things we're talking about here. Apply evaluated, use evaluated. Okay, so map at, evaluate in place. So that's essentially what we're talking about right now.
I think that this project has 2 parts. The part of making a function not evaluate so much, and the part of making a function evaluate inside held expressions instead of getting stuck as it happens right now. And this thing is the second part. So we have seen the example that Itai gave at the beginning of something doing a check and evaluating too much. I think that's a separate case. So this is this second idea of having a held expression and doing things inside.
I'm sorry, can you repeat that, Jose? I got a bit lost.
Yes, so you started showing an example in which you did a check and it evaluated.
Mm-hmm.
And we didn't want it to evaluate. And then there are all this second part of you have a held expression and you want to do things inside. And we saw the example of the rule that got the square inside, but didn't evaluate the square.
Yep.
I think that's the part that we have explored several times. And that's why we need an evaluate at and a replace at and things like that.
Wait a second. So this is rule delayed evaluate.
Yes. So you see, it's the same construction I was mentioning before. How to evaluate a number inside something which is held.
Yes. Right. Okay. So you're saying rule delayed evaluate, which could either be something, it could either be, I don't know what, it could either be something like x arrow x colon greater than immediate evaluate of y, or it could be its own rule delayed evaluate.
Right.
Right. But the semantics, which we understand fairly clearly, are you go in there and I mean, the problem is that everything in the light cone, so to speak, in the future light cone of the immediate evaluation is evaluated, if you understand what I'm saying. So if there was something there where, when you picked it up inside that expression, you said, well, I only want to evaluate these pieces, then you've still got a different problem.
Right, which with
We have rule
that
condition,
problem,
right?
I have sometimes, if I'm dealing with user-defined functions, you can, and you want to evaluate sort of one step at a time, you can hack around that by, instead of having the function, but replacing with down values of the head, right? And that'll do sort of one level of evaluation for you. But in general, yeah, getting, you want it to completely evaluate the function you gave it, but then not go into infinite evaluation. I don't know how to solve that problem. I don't know that it is solvable.
Dan on our live stream is mentioning template slot, which we indeed have not mentioned.
And we have already rule condition, which is what internally is used to solve this problem, but it's not exposed.
What is rule condition?
So you see on your notebook on your right, what it says with trick. So that's the notation we use to force the evaluation inside, which internally gets converted into rule condition.
Oh, the with trick. I didn't understand what that meant.
Here's an example of rule condition further up.
Oh, yes. What the heck is that?
Some internal implementation detail. Well, no,
well, it takes a second argument.
No. But I mean, it's some internal implementation detail of the pattern matcher, which, happens to do the right thing in this case. And I know maybe it's generalizable, but it's not like it was designed for this express purpose.
No, but
okay.
it solves one of the most important problems in all of this.
Which is just
evaluating things inside held expressions.
Right. Evaluating things inside held expressions after replacement.
Exactly.
But there are other things you might do. For example, well, okay, and so you're saying that would apply also to replace part in a held expression. And then you could use the same kind of construct. Part 3 goes to immediate evaluate of whatever.
Right. So rule condition, right, wouldn't work there because that's not really pattern matching. Right. It's pattern matching against the indices, not pattern matching against the expression.
What else would one want to do? So what about map, for example? Because map can go down the expression. I mean, if we said map at blah, 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 map at F, and then we've again on the held expression, we might want to have a, map at of some kind of immediate version of F on the held expression. I mean, in general, any function that can kind of spray another function into something And how many functions are there that do that? Are there millions, or are there only a limited number? And I mean, those are two cases. So one case is it's the right-hand side of a rule, right? Another case is something like map, if I'm not mistaken.
Mm-hmm. Right. I mean, certainly your go-to guides are going to be replace, replace all, replace repeated, map.
Notice that
map
with
add.
already does this.
What?
With already does this. Okay, so the question is, what functions?
Well, with combined with condition.
What do you mean with combined with condition? What? Why does it?
That's what you mean. Right. Well, yes. Well, with right, it lexically replaces X with value.
Right. So with already does it, which is the same thing that the slotty thing does, right? Template slot and so on would also do that. Okay, so this is where we should be looking. So now, of these, I'm not even going to imagine what nothing does in the case of unevaluated expressions. I mean, these, yeah, okay, so there's another case here, okay? Okay, so e.g. reverse want to apply a function to the top level of an expression structure, but not below. See what I'm saying? That's even another case. Because one thing is the forward light cone business of as soon as you seed it, the whole thing is turned to dust or whatever, right? As soon as you seed the thing, every sub-expression is going to be evaluated. And the other case is that you only want to deal with the top level of the expression. See what I'm saying? Like in reverse.
Right.
I can
and
imagine
that's the thing that's basically impossible. I mean, I know of no way to do it, even with hackery. I mean, right, basically the only way.
No, you could do it for specifically for reverse by wrapping and unwrapping the arguments. So for example, okay, let's say, so this could be a top level only apply of F. Okay, and what does it do? It wraps F onto G of XYZ. Okay, wraps XYZ, does the operation, gets out, unwraps. That would be how you would do it.
Right. Yes.
So it's kind of like a, yeah, go ahead.
Or yeah, I mean, and of course there are variations of this, like sliding and unevaluated in the right place and then releasing the hold. But yes, there's sort of no way to do this in a single step, right? You have to do it in sort of 3 steps.
Well, but basically what you have to do, and this is sort of an interesting concept, is the wrapping and unwrapping business. In other words, what you're doing is, this is sort of a withheld wrapping, which says wrap some sub-expressions, do an operation, then unwrap. I don't think this is completely, I mean, look, what I'm pretty convinced of at this point is that there's no slam dunk, we just need one idea, we're going to solve everything. This is the thing where we're going to have to do a certain amount of, where the question is, can we make a somewhat intuitive interface to this gingerly touching things that might otherwise explode? Okay, so within a held expression, by the way, I mean, we need to understand, within a held expression, first thing is we want some kind of immediate evaluate. Okay, so immediate evaluate would normally immediate evaluate of expr just evaluates everything inside expr.
So let me put it this way. So rule first evaluates, then matches, then inserts. Rule delayed is first matches, then inserts, then evaluates. And there's a third possibility, only one third possibility, which we are missing, which is first matches, then evaluates, then inserts.
Okay, hold on. So you're saying.
So I say again. So there are only three things to worry about: evaluating, matching, and inserting.
Okay, so that's evaluate, match,
and insert. And match always comes before insert. So there are only 3 possibilities, not 6.
Okay. So then what are you saying? You're saying replace.
Rule is evaluate, match, and insert. Rule delayed is match, insert, and evaluate. And we are missing a third rule, which is rule condition, what rule condition does, which is match, evaluate, and insert.
You're right. You're right. That's nice. Okay. Well, that would be a very doable thing to put that in. I mean, whether it's a sort of a wrapper for rule delayed, which is what I kind of prefer. But okay, but so that's that case. But now we've got to now consider nuances to evaluate. Right? In other words, is it all the way down? You get what I'm saying? This isn't just for rule.
Right.
I mean,
it probably has to be all the way down. I mean, because what
I'm
other
thinking
sort of wrapper
this case. No, I'm thinking of this case. Right. The nuance is instead of just hold of look, what this is withholding. Withholding, where apply withholding of f onto expr. Okay, and what that would do is this thing that I'm saying above here. So apply withholding would say basically, it would be, f of, well, this thing here, right? I mean, if I say, I mean, here, let's write it a bit more explicitly. H of args triple blank. And what that would be is f of h. Oh my God, how to do this? Well, I mean, this is going to be held inside. And so this is some kind of weird.
Right. So it'll need to be held. Yeah.
Some kind of sequence inside there where you're mapping hold onto.
Right. You'd need to map hold onto unevaluated of list of args.
Okay, but so you got to do various horrifying things here, and then when you're finished with this, you would map.
You would map hold of x blank goes to x across the result.
I don't even understand that, but anyway,
yeah, it's very simple. Hold of x blank goes to x, and or replace at level 1. Sorry.
This thing, replace that at level 1 you're saying? Is that what you're
Yep.
saying?
Yep.
And then it's hold of the whole thing. Otherwise, the whole thing's going to blow up.
Well,
See,
I
that's
guess
the
I was
problem.
assuming that AH was already.
No, no, because this is inside. This whole thing is within. The whole point is that this is inside an immediate evaluate. The immediate evaluate is an apply withholding.
Okay, well then I guess you'd need.
It's a little bit more complicated, but I think we all agree that there's a thing you could do here where you basically, evaluate with inner wrapping. I hadn't really thought of this before, that we could have a systematic way of inner wrapping, but we might have to define, where you wrap, e.g. levels, part numbers, etc. Where you wrap, it auto wraps and then it auto unwraps. In other words, it treats, i.e., treating certain sub-expressions as atomic. During the operation. And that's the key idea. So what you're saying is one key idea is that we evaluate before inserting. I'm claiming another key idea is we are doing evaluations in which certain sub-expressions are treated as atomic. I think both of these things are quite useful. Free on our live stream else. It's a good reason why one does not want to replace on levels whose depth is a prime or something similarly arbitrary. Only for solution I can see as a function is applied all over the AST, but has access to a means to evaluate in different local and global scope. Why is it difficult to evaluate why can't you just do a map at onto, why don't you just get, well, it's a little bit messy, but I would think you could do a map at onto the, does map at allow patterns? But can you do that? Can you say map at of ABCD?
I don't think so. Replace part does, but not the
Yeah,
others.
replace part does. Yeah, so you can't use a pattern that says to blank or something.
You can do two all.
Right. No, I mean the extensions we've talked about with map at.
Okay, so that works. So universal patterns work.
No, a few universal patterns work.
Okay, fine.
Or it's map at. Maybe the map at is the one exception that does every right. We've talked about this the last few months and making all these at functions consistent. So I guess
and I think replace part is the unusual one, and it is
does very well with patterns. Replace part can do arbitrary patterns because it's only dealing with parts. It's not dealing with expressions that could explode. All right, we should wrap up here. We are making progress finally with this inert expressions question, I think. I think we've got a limited number of functions here, like, immediate evaluate or whatever we call it, and like this evaluate with withholding. These are both, I think, interesting and useful things. Whether activate part is useful, that might also be useful. But we've basically got two branches here. We've got two fundamental branches.
Right. Is activate part any different from map at, activate, expression, comma part?
Map at.
I was about to say, if you combine it with the immediate evaluate, then it is.
Okay.
It's like a map out of an immediately evaluated and activate.
Right. But so we've got two basic branches. An activate, which is, inactivate sprays, I don't know what, protection, sprays.
Pixie dust?
No, it's freezing things. What is the right? It's like, what is that? Carbon? What the heck is that called? The
Carbonite, the thing that that Han Solo went into.
Yeah, right. Sprays carbonite everywhere onto all subparts. Whereas, but leaves the overall structure exposed. Whereas hold puts a, I don't think this, oh, it's very confusing. Puts a boundary, you know, a protective boundary around everything. But as soon as you extract anything, but as soon as you pull anything out, it'll blow up. But the subparts are not protected. Yeah, well, I think we're making real progress here. This is great. Let's bring this back another time. I really think this is promising. I think we should think through these two cases basically.
Okay.
I don't know whether this is a principled thing, the supply withholding. I kind of think that there is a principled way to do this. I've never thought of this one before, because that would allow.
Right, but if you're, well,
Go ahead.
I guess, right. Well, I guess the problem is, I don't know that this necessarily goes into immediate evaluate. I think it maybe is its own thing, right? Because you'd want
I
it.
agree. It's a separate function.
Right. Okay. Right. In which case it doesn't need to wrap the whole, because the holding will come from
the outer
that
thing. So
side.
you could say immediate evaluate of apply withholding.
Right.
No, you couldn't.
No,
No,
not that.
you
But
couldn't.
I'm saying that apply withholding would probably need to be also specially treated by the function that's interpreting things, just like immediate evaluate.
Fair enough. Hey, listen, for everybody's purposes, this is in the code transformation subfolder.
Yep, I got it. Thank you.
Okay, well, to be continued another time.
Okay.
Good stuff. Thanks, and thanks to folks on the live stream. See you.